exercise set A question 2. This question basically tries to give you more practice with normal distribution and working with log return. Basically, to do this question, you need to know various properties of normal distribution, such as sum of normal random variables and linear combination of normal variables. Now let's get down to the first part A. It requires us to calculate various quantities. The first one is the probability that RT is less than minus 1. So, of course, we are allowed to use some software to do it, and so let's get down to it. Going to the solution manual. Here we can see the solution using various software like MATLAB, Excel, and R. The important point here is that make sure to go to the software help or just Google it to see how the software parameterize the distribution. For example, there are some software that they use variance as a parameter of a normal distribution. There are other software or usually other softwares use a standard deviation as a parameter of the distribution. If you happen to work with some software that are sort of related to this Bayesian statistics, you see some weird parameterization. For example, they use the inverse of a variance called precision as a parameter of a normal distribution. If you don't take this into account, your calculation will be definitely wrong and you get weird results. So the takeaway of this part is that make sure to go to the software help. For example, if you just started learning some new software like R, MATLAB, or let's say, for example, you just started to use some open source software like Python, and you happen to need this normal CDF in that software, simply go to the Google and Google it and see what comes up. And there are various communities and various documentation you can find here on Google. For example, here there is some package called SciPy for Python that you can use, and apparently it gives you some class like normal. It takes some different approach from other softwares. It gives you a class that if you just read through the document, you will see that if you wanna use the CDF, you need to use this method of that class for CDF, and it accepts X and location parameter, which is the mean, and a scale parameter, which is the standard deviation of this normal distribution. So that's it for this section. You just make sure to read the software documentation. So let's get down to the next part. These two parts are actually of the same nature. That is, you need to know this property of normal distribution, that a linear combination of normal variables will be a normal random variable. So let's get down to the solution manual. In this part, we are asked to find the distribution of the sum of these three random variables. The important point to note is here that since y is the sum of normal variables, it has a normal distribution. All that is left to do is to find the parameters of this distribution, which we use this standard results from the probability that the expected value of the sum of or any linear combination formula, we use that, and we will find that this expected value of y is, for example, here 15%. And for the variance or standard deviation, of this normal distribution, we use the variance formula, and we use this independence property, and we simply drop the covariance factors. Note that here there are only variances. All the covariances will be covariances term will be 0, and it's a result of the independence that is given in the question statement. So at the end of the day, we find the variance and expected value of this constructed new variable, which is called y, and it has a normal distribution with mean 15% and the variance of 75%. For the next part, it still uses the same property that linear combination of random variable is a normal distribution. So we simply find the expected value and variance of this distribution, and after doing the calculation we come up with these two numbers. So the final answer to this question is that y(t) has a normal distribution with this mean and variance. So to sum up, whenever we are faced with a linear combination of variables, it happens a lot in finance that we need to find the linear combination of random variables. If they happen to be normal, so we know the distribution. All that is left to do is to find the parameter of that distribution, and which we use these standard results and find their mean and variance as a final parameters of this distribution. Now going to the final part of this section, we are required to find a number here called Q of 5% in such a way that RT, the probability of RT less than that number is 5%. This is in probability. Here in hints we have this hint that it is called quantile, and it is directly related to a very important concept in finance which is called value add risk. They call it VAR. For example, when they ask you to find 5% VAR, at the end of the day you have to calculate this quantile. So it is a very important subject, but in this course we may not really get into it. Anyhow, it is good you know that how to calculate this quantity. So going to the solution manual, here you can see again various softwares are used to calculate this quantile or quantity. Again, the same important points that I mentioned in the first part, previous part, carries on here. Always go to the software help and see the parameterization and how they calculate this quantity. After, for example, going to that software, when you know what you are looking for example, MATLAB has a sort of descriptive name. It calls it a norm inverse of a normal variable, or in R it is called Q norm, quantile of a normal distribution. Anyhow, if you know what you are looking for, you can use this software to calculate these quantities. The old-fashioned way of doing this sort of calculation is that, for example, they give you some sort of table that all the probabilities of a normal distribution is listed in that table, and you need to learn how to use such table to come up with the answer to these questions. Well, this is the end of part A of question 2, exercise set A. Now going to part B, it asks us to find the probability density of S tilde. What is S tilde 3? S tilde is defined here and here. This is basically related to this RT, which is a log return of these prices. So going to the solution manual, this is just a rearranging of what is given in the question statement, which states that at every time the S tilde is equal to its previous value plus RT. So when we've got this, when it is mentioned it has at any time, so we can rewrite it in terms of S tilde t minus 1. Again, we can repeat this procedure and till we come to time 0, which in the question we are meant to find the distribution of S tilde 3 as seen from time 0. So at time 0, all these variables still will be random variable, and using previous results, we know that these are going to be, this sum will be a normal variable. This is a constant, a known value at time 0. So this whole expression will follow a normal distribution. Now that we know the distribution, all we need to do is to find its parameters, which happen to be its mean and variance. Using these standard results again, we can find these parameters. So the final result is that S tilde will follow a normal distribution with this mean and with this variance. This is the end of part B of question 2, exercise set A.